Welcome to 4 Quarter Lives, a podcast exploring the profound impact of longer lives and careers on everything: countries, companies, couples, and careers. I'm Avivah Wittenberg-Cox, and on this week's 4 Quarter Lives, I talk with Saher Mehdi, scientist, founder, and fierce advocate for equitable longevity. Trained in molecular biology and epigenetics, Saher has worked across Europe from Oxford and Sweden to Belgium before returning to India to apply her insights at scale. She brings a deeply personal and scientific lens to the question of how we age and what it will take to ensure that longer lives are not just for the global elite. We talk about the biology of aging and how it's different for men and women, about mitochondria, telomeres, and that mysterious second X chromosome. And we explore why longevity science needs to move from elite biohacking to inclusive public health, especially in a country like India, where the population is aging rapidly but invisibly. Saher's reflections on unlearning, equity, and culturally relevant science are as refreshing as they are urgent. Welcome, Saher Mehdi, to 4 Quarter Lives. Delighted to have you with us.
Thank you, Avivah, for having me on the show.
So I want to start our conversation a little bit in your very interesting mix of personal and professional journey that I've put under a title of From Molecules to Meaning. You started out deeply immersed in the world of molecular biology, epigenetics, and plant aging. Give us a little context. What originally drew you to science and what has kept you there?
That's a great question. I think rather than me choosing science was the only thing I was good at, and science chose me instead. And my love for all things science and aging began in a very unassuming, ordinary place. As a child, I remember this is basically a photograph of my grandmother lying next to her and playing with her loose skin on her hands. And I used to just love playing with the skin and her nerves in her loose hands with all the wrinkles on her hands. And I often used to ask her, "What happened to you, Grandma?" And I used to admire her wrinkles, the weathered skin, and which is full of stories. And even before I knew anything about aging, I could feel the history written on those folds. That quiet intimacy, I suppose, stayed with me. And then I think in science, what kept me is wonder and curiosity, the pure, unfiltered curiosity. For me, science is like falling into that Alice in Wonderland rabbit hole, because once you are in that hole, you can be amazed, you can be puzzled, and sometimes completely spun around, but you really don't want to come out. Every answer leads to a deeper question. And I think that fascinates me about science, absolutely to my core. And during my PhD, I think that was kind of came into being when I realized that all fancy genome and human genome project was almost completed around the same time. That everything that we call genome, the code we are born with, the sacred code that we are born with, does not actually tell us the whole story. It's like a hardware of a computer from outside. Yeah. The real magic would actually happen in the software, which is our epigenetics, the subtle switches, the signals, and the stories or the influences that shape us, who we become. That actually fascinated me and kept me hooked to biology of aging.
That's a very beautiful origin story. And I love the image of you playing with your grandmother's skin as original inspiration. Now, you've lived and worked a little bit all over in the UK, Sweden, Belgium. Now you're back in India. Give us a little idea of how these cultural, institutional shifts might have shaped your perspective on science, health, and aging. It's very different across those different cultures.
It is indeed, Avivah. I started in UK at Durham University and followed by at Oxford for several years. And actually, that's where I learned most of my science that I know today. And it felt like a sacred ground because while I did my undergrads in India, I was not really trained to really do science. Everything I learned at Durham and at Oxford was deep, rigorous, and precise. That's where I learned how to respect the research method that is methodological, that is slow, And it pursues the pursuits of truth or hypothesis, how it's derived and how do we pursue science. But it also was the place where I began to see that aging and health in general is not just a biological process. It's a very layered process, which is shaped by several things, environment being one of this, opportunities and access another one. And when I graduated and moved to my other roles in Sweden and Belgium, where I was independent researcher, Sweden, I suppose, was awakening again because it's a beautiful country which is very organized, and aging itself is embedded in the process because aging is very gracefully woven in the social fabric of Sweden, I would say. It's very quiet, almost effortlessly embedded in the dignity of how people are growing old. You can see old people living with that dignity because it's a healthcare system that is proactive, not panic-driven.
Yeah.
And the science is also very deeply human. So they care about from you from the very start, the day you are born to the day you basically get to your grave.
Thank goodness for Sweden in so many dimensions.
Exactly. I think they are very progressive when it comes to human experiences in many aspects. Whereas Belgium, I think, sharpened my thinking further because it was the first time I was exposed to real human hearts and real patients, so to say. And also because I was working in a hospital organization, I could see how systems work, how real people come to experience the healthcare, how policies, data, and access interact together to create a healthcare environment. But the life-changing moment or the eureka moment for me was when I saw a human heart, a 45-year-old human heart on my dissecting table, full of fat, double in size. And that was like, wow, how did he ended up on my dissecting table like this? And I think that really changed my overall thinking about health, that health is not really just the stories or the research that we are doing. It is deeply embedded in our societies. And even in a developed society like Belgium, what are the kind of resources that are available for population level changes? And that's when I started thinking about health at a population level. And then everything changed. I returned to India, both for personal and professional reasons. And everything I learned in UK, Belgium, and Sweden got stress tested, I would say.
And scaled, stress tested and scaled.
Absolutely, because in India, aging is rapid, it's unequal, and often invisible.
People don't really think of India as aging. Most people will think of India as an extremely young country. Can you give us a bit of context on just how fast India is aging?
Absolutely. I mean, the data suggests that 1 in 6 Indians by 2050 will be over 60. So before we even become a developed country, we will be an aging nation. And that's phenomenal. And it's the first time in human history in 2024 and 2025 that the number of people above the age of 60 have crossed the number of people under the age of 16. You know, that's phenomenal if you think about in a country size of India. And that's predominantly of two major reasons, I would think, because in India, there has been a drastic decline in the fertility rates. And globally, there has been a drastic decline in fertility rate. But India stands out above the global scale very drastically. For example, in past 50 years, in the 1950s, it was average Indian woman would produce about 6 kids. But now in 2023, the urban stats is 1.6, and in rural areas is 2 or 2.1, which is really, really low if you think.
Yeah.
I think that's the reason which is driving this huge aging population, especially in a demography like India.
So you get back to India after doing a bit of a longevity cruise around Europe, and you start 2 companies, one after another. Tell us a little bit about the thinking. What inspired you to create them, and why those ones at that time, the first Wise in 2018?
Yeah, I think it's a story of both my naivety and urgency and curiosity mixed all together.
First startups usually are, aren't they? A mixture of those things.
Exactly. And I think my enthusiasm that as a young scientist, I thought that what I know is phenomenal. And if I can apply that at population level, that would change the face of healthcare. And I think that's a very good ambition to begin with. But when you start implementing it, it's a entirely different story. So I came back in end of 2017-18 and established this company, which was called Wise, thinking that, we are giving a better healthcare options for people. That was the idea behind it, that we will make people informed about the risks that they carry, the health risks they carry, by using multidimensional data, right from their genomics to, life influences, their lifestyle data, their family data, their blood data. And if we can give them a risk assessment of what, risk for chronic diseases, what risk for allergies, and what risk of fitness risk they carry, we can help them mitigate those risks early on. And then we can give them a plan, if they would stick to that plan, that will help them mitigate the risk of these diseases.
So very much a preventive slice based on individualized analytics.
Exactly. And I think back then, this was a newly coined term, which was precision health. So we called ourselves India's first precision health company, which was essentially a preventive health company. And I think now the preventive health have suddenly become fashionable post-COVID. But back then, it was a necessity. And in my head, clearly, it was a necessity for a diabetic and a chronic disease capital of the world, like India. And then we successfully ran
Tell us a bit about that. I did not know that India was the chronic disease capital of the world. What's driving that?
There are several reasons that is driving that. And I think one of the key, most important reason that is driving is our genomics is very different from rest of the world, but also our epigenomics is very different, because India is a highly diverse country, which is divided into 5 major racial or ethnic groups. And then it has about 22,000 sub-ethnic groups, so to say. And every group has its own diet, its dialect and culture. And in India, being such a crowded country, there is not really space to be active. We say that in order to live a long and healthy life, all you need to do is eat good food, eat good, clean food, and breathe good air, and, exercise yourself.
Yeah.
But that conventional wisdom does not apply to everyone. And especially in an economy or a country like India, where there is hardly space to walk around. There are hardly any green spaces to walk around. The air is so polluted that you can't really breathe. Breathing in the air is a hazard itself.
Yeah.
There is no clean water. To 50% of the population, there isn't hardly clean water. So you have to use purification systems at home, even for taking a bath. Clean food is almost become a dream here, because you have to stick to organic food. And if the soil is not bleached, then you don't know what you're really eating. So simple things like that we think are kind of taken care of in the most developed part of the world are actually a challenge in India. And I think that slowly, along with this burden over the generation, has become a chronic disease capital. So India is a chronic disease capital for the 2 major metabolic diseases that are cause for mortality and morbidity across the world. It's a chronic disease capital for diabetes, and it's a chronic disease capital for heart disease as well. And it's catching up soon on obesity and childhood obesity as well. And I think it's not just a thing of generational effect, but it's also systems. There are no systems here to tackle these diseases in the first place.
Yeah. Okay. So a medley of challenges at mega scale that you made a jab at.
Exactly.
And let me perhaps segue then to dig a little bit deeper into what your work has been focused on in these companies. Because a lot of it, you're exploring really the cellular mechanisms of aging. Can you give us a bit of what are some of the most promising discoveries emerging in this field today? And what were you trying to pull out of that research and into the scale of India?
Okay, I'll begin with preventive health. And I think that's the inherent term that we use to solve a problem like chronic diseases. So this thing that we measure our age, when we talk about longevity, we talk about chronological age, the date of birth that we are born at and the number of years that have passed since our birth. That's our chronological age. But this largely, we used to believe that our body is equivalently aging as compared to the number of years that has, passed. But That's not the truth. Our body and our entire body as one unit can be aged much slower or faster than our chronological age. And each organ within our body, be it brain, be it your liver, be it your gut, are aging at different speeds. And one thing we know that faster aging now is the core cause of all the chronic diseases. So back in 1990, there was a big study of epidemiologists who wanted to see what happens if we cure all types of heart diseases and all types of cancer and all different types of heart diseases, be it arrhythmia, be it cardiac arrest, be it, cardiovascular disease and arterial diseases, everything. What happens if we can cure cancer and heart diseases? How many years do we add to human lifespan by curing these two big diseases?
Yep.
And they found that, to their surprise, if we cure these two big killers, we are only adding up to 5 to 7 years to human lifespan. And in contrast, if we start to tackle the cellular mechanism, the key cellular mechanism that is driving faster aging, we can add up to 20 years to human lifespan, healthy years to human lifespan. And that was, I think, the beginning of this whole revolution of longevity. And that's where the whole revolution back in Silicon Valley and California began when in 1990s. And now I think aging at its inflection point, where we know or have the understanding of the key cellular process that drives aging, not just in humans, but in other species as well. But a lot of the interventions that are we using today to reverse those agings or slow down that aging are not really tested in humans. So that's where we are.
So what you're saying is that really it's aging itself that's killing us, as opposed to what we think of what's been hurting us has been these chronic diseases that we haven't made all that much progress in eliminating for many decades.
Exactly. That's the crux of the matter, because the key processes that drive cardiac disease or cancer or diabetes are deeply rooted, are the mechanism that driving faster aging itself. So at the core of everything, your cells are in a race to reach stop point. And the faster you go down the slope, the faster you are going to catch diseases. And the whole science or our understanding now is progressing to slow down this process, to take a deep breath and say that, okay, is there a way to that we can, in a guided or regulated manner, we can slow down this faster aging? And can that help towards preventing these diseases happening in the first place?
Okay, so that's where we are, trying to slow down cellular aging.
Indeed.
You've also mentioned that men and women might age a bit differently, even down to the level of mitochondria and telomeres. Can you try and unpack what some of those differences might be for a lay audience that may not know the science or the terminology?
Yeah, I mean, for a scientist, I would say there's this, I think, blindness towards what is available in public knowledge, what is public knowledge and what not. So I always believe that everybody knew that there are men and women age differently. But it is actually, most of us do not understand it at the level that cellularly, men and women, the aging difference is very deep, right down to the cells. And as we talked about earlier as well, let's begin with mitochondria. So women, always give this analogy that women are like these reliable, energy efficient cars that have, power systems built inside them. So think of mitochondria as the power plants inside the cells that in women are passed down from the mothers. And in men as well, they get it from their mothers. But these are highly efficient and resilient when it comes to their function. These energy-producing cells or energy-producing organelles are highly efficient in women, especially before menopause, because estrogen also protects these mitochondria from degrading and dying off as well. So women are generally often tend to live more because of the effective or efficient energy metabolism. Whereas men are more like high-speed cars. Their batteries is for consumption, they are for speed. And hence, they exhaust their mitochondria much faster than women as well.
That's fascinating. I think it's a great metaphor. The resilient, energy efficient, saving car versus the high-speed Ferrari burning everything up as it goes. That's very graphic. And I think people have absolutely no idea that such a difference exists. I think it's been relatively little reported.
Yeah, and I think it's astonishing how true it is that it's not just evolutionary important, because think of that when we were hunters and gatherers, it were men as a tribe. It was the women who would look after the child and keep them safe and everything and defend them from the enemies. But it was the men who was running around to catch to hunt for the family. And they had to have the speed and agilance of a lion or a cheetah So that is inside, built in our system in a very evolutionary manner. And I think if we do not use our bodies that efficiently or in that manner, we are actually burning out or consuming our mitochondria in the wrong way as well.
Fascinating.
And then we left the telomeres as well.
The telomeres. Yeah, we love telomeres. Go for it. the super important little telomeres.
Yeah, indeed. And I think they're more studied now, and we did not know much about them other than that they erode every time the cell divides. There is a bit of telomere that is lost. So think of them as the plastic tips on the shoelaces. And every time a cell divides, the chromosome opens, these telomeres were lost. And they naturally shorten with age as well. And if you think that grave number of 120 years of human life is kind of related or embedded in these telomeres as well. But here's the twist. In women generally tend to have longer telomeres than men. And also the loss of telomeres is slower in women as compared to men.
How much longer are they?
I don't have the stats.
No, there's no average. Yeah, okay.
Yeah, but I think what the research says as such is the estrogen plays a huge role. And also the extra X chromosome that we have that we think is inactivated and not in use also comes into play when it comes to the protective role of telomeres as well.
Yeah, so tell me more about this double X. This is something I've just been reading about this past year. And so this famous second X that women have, how does it work? It seems to click into effect somewhere after menopause. Is that right?
Yes, I mean, it really comes into effect every time our body is stressed, so to say. So the earlier belief that how women have two XX chromosome that give them their identity, and men have X and Y chromosome. So in women, one of these X chromosomes get inactivated very early during our development. And this activation is not perfect, so to say, and it's leaky, or as if it's always hiding behind the curtains, and will only come into play when it's needed. And earlier it was thought that this inactivation in women is absolute. But that's not true. And the more we are studying, and we found that this is highly leaky, and especially some genes manage to escape, or so to say, functions like genes that are responsible for immune regulation, for brain health and cellular repair are kind of covered. So when our X chromosome or the genes get switched off or get, kind of depleted, this extra chromosome from behind the curtains, or so to say, the quiet twin comes into play to give us this extra immunity or brain, a boost in our brain health and in cellular repair as well. Whereas in men do not have that extra X chromosome to have any backup as such.
What might be some of the implications then of these gender differences for the whole preventive medicine? What might one want to suggest to highly efficient cars versus high-speed cars in taking care of themselves differently as they age?
Yeah, I mean, the fundamental understanding is the need. Our needs as a women body is very differently made from a man's body. And women are not just small men, as we were always taught in science. And I think science, I would not blame it as well, because as scientists, we try to minimize the noise to make our hypothesis or experiment type controlled. So every time a scientific experiment was designed, in the hypothesis, we would not include women, thinking that their biology is too like stock market or too volatile to be taken into consideration. And that led to most of the scientific studies about human biology being male-centric and ethnicity-centric as well, I would say.
Just for simplicity, because men have less up and down of
exactly
changes across the month or the year. And so it has been just standard to take out the noise and make it as simple as possible.
Yeah, not just across month, I would say, but also across the development. So when you are looking at men in their teens as compared to women in their teens, or men in their 50s or 40s as compared to women in their 50s and 40s, the graph would look drastically different, And that makes me bring to the very interesting and very neglected topic is out of even the studies that really compared women, they would never take women above 50s, the menopausal women or the premenopausal women, even in their late 40s. And the reason being that there was so much stark differences in the levels of estrogen and progesterone and even testosterone in women across these aging as compared to men, which is really a flat line that most experiments did not consider them. And even they considered animals which do not, menstruate. So we are really looking at biology in a very male-centric manner. And I think that's not how we can solve for longevity, so to say.
What would biology with a female lens look like? I mean, the variations across the life course for women are pretty constant, I assume.
They are indeed. So women, I would say that one thing that is fundamental in women is the role of estrogen. So it's almost like a gift until it's not. And it's almost that the gift is snatched from you during your menopause. And I would like to quote one of the famous studies, the Women Health Initiative, that kind of misled a lot of information or the repercussions of women health that we see today. That there was this study that came out that basically they gave women some hormone treatments to the women who were in the menopausal stage and others who have passed the menopausal stage. And they found that there were, effects on their heart and their skin. And also they had higher risk for metabolic disorders and things like that. But that study was, when other scientists or global community looked at it in a very closed quarters, they found that there were a lot of misreadings in that experiment. And that really decided the 2 decades of knowledge about women's health that we know today. Even in countries like India, where healthcare standards are quite high, you would not believe that my gynecologist, if I go and ask her for a hormonal therapy at 44, she would not give me, because it's not in their curriculum, really.
Right. Yeah. No, we lost a lot of time from that one unfortunate study back in the US in 2001, right? The Women's Health Initiative. Such a shame, such a regression. Yeah.
Yeah. And I think that makes us realize that in science as well, we need to have this humility that we do not know all. And it's also ever changing, that you need to be ready to agree to the mistakes you have committed, really.
Yes, that is still in hot debate. So where do you think we are in this emerging longevity field? With everything that we said, what do you think of this whole rise of biohacking, a whole raft of California startups targeting the world's 1%? I'm curious, from an Indian perspective, are we in danger of missing the broader picture of global human health?
Absolutely. I think this is one of the most urgent conversations that we need to have in the longevity space right now. With the rise of biohacking, supplements and cryo chambers and maybe $1,000 a month supplement protocols are all exciting and making, headlines and attracting investors and even promising big breakthroughs. But in order to be really honest and make longevity accessible and affordable to all this is only catering to the 1% of the population, the super rich. And the danger here today is that we don't want to make longevity a elite wellness game. It should be a public health movement. And I think we are more and more, as we are growing our understanding towards longevity, there is very little noise, or I would say there is a little voice in public health equity that needs to come in order to address or prolong that health span that is needed at a global scale across societies, across classes as well. And I think especially like in a country like India, which is still battling chronic diseases, and even there is simple issues like nutrition, lack of basic necessities is a challenge for most of the population. Something like this can create a highly unequal society. So I think for a broader picture, and I think what as in responsible individuals and somebody who's informed, we feel like the longevity needs to be equitable, not just focused on extending the life of the super rich, because where are we heading then if we do that? And also, I think the other point, other than equity, is the cultural relevance. What is true for somebody, if aging is 80% epigenetics and only 20% genes, then there should be a cultural relevance. What is true for somebody taking a cold plunge in Sweden might not be true for somebody living in 50 degrees in Delhi,
Yeah.
And I think that's very important, because when it comes to cultural relevance of these longevity interventions, we never even think about it. And we think them as that my experience is a universal experience, but that's not true. Your N is one. And if you want to apply your N of one to somebody else, you first need to find out their data. And the last point I feel is also it needs to be functional and not just futuristic. So a lot of time we talk about longevity as a life extension, that we want to live up to 200 years and, make these hacks with best possible peptides and all these. While we are still unable, globally, chronic diseases are on rise. We are not able to tackle simple issues of metabolic diseases, sugars and blood pressure and chronic inflammation, stress and nutritional deficiencies, let alone tackle an issue like aging to think about. And I think everything is connected. So we need to go back to our drawing chart and see where we need to begin and think about more functional things that we can do before we start thinking about the futuristic changes we need to make.
So what does that mean in an Indian context? What are you dreaming of? And what are a little bit your next steps and focus? You put your company a bit into stealth mode for a time and have been consulting. If you were to address this health inequity issue at an Indian level, what's the dream? What would you look for?
Yeah, that's an absolutely amazing question, and something that I actually thought of, but not thought of it in that depth, really. So in Revise Health, which is the new initiative that we started and still in stealth mode, the aim was very simple. So now the science is advanced enough to quantify our biological age. And we can do that with good accuracy, I would say, medium to decent accuracy, just using blood markers or surrogate blood markers of epigenetic DNA markers. And there are several methods out there, while there are no methods specific to Indian ethnicity. So what we were trying to do at Revise Health was to create a platform-based approach for ventures like healthcare startup, healthcare companies, even age tech companies, who could use this platform to quantify aging at a population and at an individual level to begin with. And by using those insights, give very personalized interventions to individuals and at a population level. Now, the sticky point is that this whole platform was designed to be a direct B2B solution.
Yeah.
And I feel that while I'm saying a lot about that we do not want to serve the rich and everything, these companies are also serving that debate. And I think the point of dilemma is, how can we make this platform accessible for public access, free access? So can we have a freemium model where anybody could upload their blood data online and for Indian ethnicity and get a pretty accurate or decent starting point of their biological age or say organ ages to begin some sort of guided interventions rather than hitting the bullets in the dark. And I think of it on a primary care level, if we can, using this system, if we can make, for example, hormonal testing available or hormonal age available to every woman who is in perimenopause or menopausal stage, we can actually solve a lot of issues that women are facing today. For example, if we know that you have a family history of metabolic disorders, if we can make simple metabolic testing, sugar testing, and blood pressure testing free of cost, accessible to public health in primary care at a nation level, then we can solve a lot of things. So little interventions we are thinking about, but I think we are still in stealth mode because we don't know what is the right starting point to apply it really.
Okay, so that's the work of the next few years, finding the right starting point to scale this very personalized analysis of people's biology and give them actually right-sized, relevant interventions.
Exactly.
Well, I wish it for you, Saher. We are counting on you and your knowledge. Let me close perhaps with a more personal question about your own aging. You're just coming to the last chapter of your own second quarter. How would you summarize your Q2 in a word, and what impact would you dream of having in your third quarter?
Wow. I think my second quarter was a reckoning or unlearning everything I learned in the first quarter. So it was a reckoning with the systems that didn't serve, science that did not tell the whole story, and then parts of me that I did not know really existed. Me as a mother, me as an entrepreneur, I never thought that I would one day become that.
Yeah.
So it was really a lot of unlearning, questioning the beliefs that I built through several years of research work, getting bruised, getting hurt, and then rebuilding, burning out, and starting again. I think from curiosity to conviction, from studying genes to watching people age and suffer in real life in India, it was all very messy, bold, but I would say deeply human for me in the second quarter.
So what are your wishes for Q3? Where are you headed? Yeah, that sounds like a very typical female Q2, the impossible juggling in a system designed not for us, that you have to redesign and understand where you stand in the midst of all of that. What's next, now that you've understood all that?
I don't know. As I said, it's unlearning. Whether I've learned or not, I don't know. Only the time will tell. But I think, as you said, the quarter three, the third quarter for me is about really redesign and rebirth. As I would like to put, that there are really, if we can, in very little, in our minute ways, can tell the stories about aging differently, make it more human, make it more equitable, and make the aging story full of vitality and not just about hacking and futuristic, then that will be a big leap in our understanding of the aging process itself. So if we can see it not just as a decline in our body, but something that our body is going through, and that we need to be, acknowledge that understanding at an N of 1 and take it from there. I want to shift our longevity science from these luxurious lab-based interventions to something that can be applied to everybody's life in a very minute primary healthcare level. Something that is more culturally relevant, that is more gender specific, and something that is accessible and affordable to all. I think if I can do that in my quarter three, I think I would be very, very happy that I left a legacy worth leaning towards.
Saher, thank you so much for your ideas, your messy Q2 pushing and unlearning. I love the idea of Q2 as a reckoning and the discovery of all the roles that you will probably grow into and redesign in Q3, mother, entrepreneur, founder, and Indian woman. So thank you so much for taking the time to share all of your wisdom with us. I look forward to your next steps.
Thank you, Avivah. It was a true privilege to speak to someone like you with so much experience in the field. And I wish you all the best in your endeavors as well. Thank you so much for having me.
Until next time, we'll be tracking each other then.
Sure, we will.
Bye-bye. See you soon.
Bye, Avivah. Thank you so much.
For more thinking about the impact of our 4-quarter lives, you can read my column at Forbes and subscribe to my Elderberries newsletter on Substack. Let's design lives that aren't just longer, but better.